Hello again. Thank you for watching and studying math with me. This video is about roots and radicals. Either 3 or minus 3 is a square root of 9, since you can square either number and get 9. But in math, we use a symbol and talk about a concept called the principal square root of a. If a is positive, it's represented by the principal square root of a, and that means the principal square root of 9 is 3, not minus 3. The principal nth root, like cube root or fourth root, is written this way, and when n is equal to 2, the square root, you don't usually write the index, and this symbol is called the radical sign. To have single value for all roots, not just square roots, and to consider only real roots, we define the principal nth root of a to be positive if a is positive and negative if a is negative and n is odd. If a is negative and n is even, the results are not real, or the roots are not real. We have properties of radicals. Here's one. If a and b are both positive real numbers, and it's not true if they're negative, but it is true if they're positive, that the square root of a times b is the square root of a times the square root of b, and often we will simplify this whenever either a or b is a perfect square, that is a square of a rational number, and those are exact answers. Often we will do approximations using the square root key on a calculator. From an order of operations point of view, all operations under radical sign must be done before finding the root. And if, more generally I guess, the even root of a negative number is called an imaginary number, and the odd root of a negative number is a negative real number. And we'll talk about that more later. So here's an example of doing an approximation using a calculator. So we type this number in to our calculator, and then we hit this key, which is the square root key on the one we use, and here I am in the scientific mode, and I get this answer. And that's how we would do that problem with a calculator. If we were doing that problem with Excel, we would type the number into a cell, and then we would use the function key up here to get the square root function, and we would get sqrt of, and then we would click on that, and that would give us an answer. And again, you can see the answer is a bunch of ones. Similarly, we can do higher roots. In this chart, I'm using the calculator to find the cube root of 27. I type 27, and I use this key, which is the yth root of the x number, and then I type 3 to represent y, and I get 3. Here's your history tab that shows you the keys that you've struck, and you see that the cube root of 27 is 3, because 3 times 3 times 3 is 27. We can also use Excel. If I'm using Excel, I probably wouldn't type a cube root function, but I would use the fractional exponent. You learned this in previous classes. So if I type 27 in this, I would say equal. I would click on the 27 and raise it to an exponent of 1 over 3. Here the parentheses are important because I want to make sure that I get 1/3 as the exponent and not 1 and then divided by 3. Let's do some examples. We're to simplify, and we're going to do these problems exactly. So the square root of 12 is the same thing as the square root of 4 times the square root of 3. But the square root of 4, the principal square root of 4 is 2, so this is 2 times root 3. And again, that is an exact answer. I would leave it that way. Here I have to add the 36 and the 144 together, and so that's going to be the square first before taking the square root. That's the square root of 180. But 180 is the square root of 36 times the square root of 5, and that's going to be 6 times the square root of 5. Again, that is an exact answer. Another question, doing a calculation here, Is the cube root of minus 8 real or imaginary? Well, the cube root of minus 8, that's an odd number and it is negative, so this is going to be minus 2, and the answer is it's real number. Now, we are in class going to be doing several problems from your textbook. Serious students, of course, will want to do more, including reading the section and completing additional work. But for now, remember that time is precious. Each day must count. Do the math. It will make you strong.